In this video, we're going to look at shading regions or graphing inequalities. Before I start, I think it's important to stress two things. The first thing is that you will need to be able to draw a straight line graph. So the equation of a straight line in the form y is equal to mx plus c. The second thing, in the video, we're going to shade the region included, or if you like, the region that satisfies the inequality. In some particular topics, we shade out the region that doesn't satisfy, but in this video, we will be shading the region that does. In the last couple of videos, we've been looking at inequalities. In the one before this, we looked at solving inequalities. In those particular inequalities, we had one variable, so it was just x or just y or just p. When we come to graphing, we can look at two variables, x and y. It won't always be both x and y, but we can use a graphical method to find the values that satisfy the inequalities. Let's start off with some notation, and then we're going to go ahead, graph some of these, and then look at some that have already been graphed and recognise what they show. So let's look at some basic notation. If I said that x was going to be greater than 1, we would look for all values strictly greater than 1. We couldn't include 1, we could have 2, 3, 4, and so on and so forth. We saw that if we drew this on a number line, we'd have an open dot. When it comes to graphing it, we have a broken line. So the broken line says that 1 can't be included. So x is greater than 1 is an example. We'd use an open dot if we're on a number line. We use a broken line if we're graphing this. Let's have a look at a different inequality. Let's say we had now that y was going to be equal to or greater than 2. If I wanted to represent this on a number line, I'd have a solid dot or a closed dot. We can see that 2 could be included. So we'd have 2, 3, 4, and all of the values greater or equal to 2. If I wanted to graph this, I would use a solid line. So if it's a strict inequality, it doesn't include it, we have a broken line. If it does include it, we have a solid line. So let's go ahead and try some of these. We're going to start off now with one variable. So it says shade the area that satisfies the following inequality or inequalities. We've only got one inequality and this has got one variable, so it's just x. So what we want to do is now show the region that satisfies this. All we start with is drawing the line x is equal to 4. We start off with this line. We can see now that it's not included, it's a strict inequality, so I need a broken line. So what I'm going to do is take my broken line and I'm going to draw the line x is equal to 4. That's just a vertical line, and we're looking now at all values that are going to be strictly greater than 4. So at this stage, all I'm going to do is shade out that particular, and we'll grab the shade, and we're going to look at all values to the right of this line. So it won't include 4. Let's just go ahead and do that. We have the broken dot, and yours will be a lot neater than this. Let's just go ahead. Hopefully you can see that if I just move this, let's just grab that and make it look a little neater. Let's just move it across a touch. So what we're looking at is a nice, and the best way to do this is get a ruler and just put it up against the line and go ahead and shade. So let's shade. So if we look at this, these are the values that satisfy the inequality. So shading, in some books you'll see that they don't keep shading. As long as you can show now that you're shading to the right, that is perfectly fine. If you're ever unsure whether you have the correct side, just test a point. So if we look now, I can see that I've shaded in the region that includes the 6. Is 6 bigger than 4? Quite clearly it is, so we've got the correct region. So all values beyond this line will satisfy this inequality. Okay, we're asked to shade the area that satisfies the following inequality or inequalities. So y is going to be equal to or less than -1. So all I'm going to do is simply locate the line y is equal to -1. We can see that this is inclusive, so I'm going to have now a solid line. So get my solid line. The line y equals -1 is a horizontal line, and it's just here. We're looking for all values that are going to be equal to or less than. So we're looking at all of the values below the line. Often students look and they look at the way in which the inequality is pointing. So if we've got now it pointing at y, it's going to tell me now that it's going to be below the line. It's entirely up to you. I prefer to see it as testing a point. So I go ahead, I draw a line. So let's put this on. And we'll just do that and just shade up to that line. So shading up to the line like so, and then it will be all values below here. So just going ahead and doing it. When you graph these, it's important now that you go ahead and write the equation of the line on. So I've put up there y is equal to -1. I would label this on the graph. In the same way I should have done it with the x is equal to 4 in the last one. So these now are the values that satisfied. So if you want to check, let's go ahead, let's take -2. Is -2 equal to or less than -1? Quite clearly it is, so I've got the correct region. So I'm just going to write up now here that this is the line y is equal to -1. So if we have lots of different lines, we would know which is which. Okay, let's have a look at this one. This time we've got two inequalities. We have one in x and one in y, and we've just looked at these. So if we look at this now, we've already done this one. We've already done this one, so we simply need to put them both on. What this will allow us to do is look at values that satisfy these two inequalities. If you come on to something called linear programming, you will do examples of where we have particular values that have to satisfy more than one constraint. So if we look at this now, and I'll do it quickly here, we've got now -1. So this is the line y is equal to -1, so just jotting that on. So y is equal to -1, and we have now that x is going to be equal to 4. We want values now here, and I'm going to do it step by step. What we want are the values, and I'll just go ahead and shade these on. We want the values that are going to be greater than 4, so let's do that. And again, I apologise that it's going slightly over that line. Quite clearly we shouldn't have that. And they're going to be all of those. So we're going to have all of these up here, like so. So these are all of the values that satisfy the first of the two inequalities. And remember, it must satisfy both. Then what we're going to do is look at all of these. So we keep going with this, keep going all the way. And then we're going to look at all of the values that satisfy the second of the inequalities. And the second of the inequalities is that y must be equal to or less than -1. So exactly the same inequality that we shaded earlier, and that is going to be just here. So if I do that, let's go ahead and that. So what we end up with are all of these values down here. What we're looking for now is the region that satisfies both, and that's where we have the double shading. So all of these values here now are less or equal to the -1, but if I look at some of these over here, now I can see that these don't satisfy the inequality that x is greater than 4, because right here, for example, x is -2, right here x is equal to 2. So we need the area that satisfies both. And I think this is easier if you're shading out the region that doesn't satisfy them. So let's go ahead and just do the region. The region that satisfies them both is going to be this one. I don't think I'm going to use that colour. I think it's a bit too much. Let's go for this one. See what this one looks like. Okay, that's not good. Right, we'll have to go for this one now, and it'll look something like that. Then we'll come across here, and it will be all of these values just here. So that now is the region that satisfies both. It's this dark shaded out region, and all I would do if I was sitting in an exam is get a pencil, nice faint pencil, put the ruler up to the line, and then go ahead and do that. So that's the region that satisfies both. Okay, let's look at another one. Okay, this one is y is equal to or greater than x. So what I'm going to do is draw the line y is equal to x. So y is equal to x is a straight line gradient 1 through the origin. So if I drew y is equal to x on the graph, we'd have now a straight line. It's inclusive, so all I'm going to do at this stage now is get my solid line, and I'll do it. Okay, let's just put there and there. So let's go through, and then we're going to have now, so it's going to look something like that. So let's go ahead and just extend that. So we come through the origin and we're going to extend it. So let's go with that and then come through like so. So that now is the line y is equal to x. Often students like to say, well, y is going to be greater than or equal to x, so we're going above the line. So we want to shade all of those values. So that's what I'm going to do now. I personally prefer to consider points, especially if we got lots of different inequalities on here. So let's go ahead and just shade out this particular region. So it's going to be all values that are going to be on or above the line. So we would do all of these, okay? And as stated, in some books, they just essentially go up to the line like so, and it is then taken that all of those values above there are also included. So the way I like to do this, instead of necessarily saying that it's going to be above the line, I like to think to myself, let's test a point. So I'm saying that this point right here is in the interval, okay, or in the region. So if we look at the coordinates of that point, and I look at those coordinates, I can see that the coordinates are going to be 0, 4. X is equal to 0, y is equal to 4. We can quite clearly see that 4 is bigger than 0. So this is the correct one. Now if I tested this one right here, this is 2, 0. So if I think to myself, is the y coordinate at least the same size as the x coordinate? Well, clearly it's not, it's less. So I would not have this particular region here. So it's all values above the line. So that's now y is equal to or greater than x. Okay, shade the area that satisfies the following inequality or inequalities. Y is less than 2x plus 1. So what we need to do is graph the line y is equal to 2x plus 1. So 2x plus 1. A couple of different approaches with this. You can set x to 0 and y to 0 and find the points of intersection, or you can simply draw a straight line with a gradient of 2 and a y-intercept now of 1. Or, if you like, you can build up a table of values. It's entirely up to you. So if you're not massively confident in terms of graphing this, build up a table of values and go ahead and do that. So I will do that on this one, and then we'll look at the gradient intercept method from it. So if I've got now x, let's put in x, let's put in y. So 2 lots of 0 plus 1. If I put in 1, I'm going to have 2 lots of 1 plus 1, which is going to give me 3. If I now put in 2, that's going to give me 5. If I put in 3, it's going to give me 7. Negative 1, we need to go down by 2, so that will be negative 1. Negative 2, we need to go down by 2, negative 3. Negative 3, that's going to give me negative 5. So if you wanted and you weren't massively confident, let's go ahead and plot the points. Remember, we've got a strict inequality here, so we're going to have 0, 1, which is just there. We're going to have now 1, 3. 1, 3 is just there. We're going to have 2, 5. 2, 5 is going to be there. And I'll do a couple this side. So negative 1, negative 1, which is going to be just there. We've got negative 2, negative 3, which is going to be there. So let's go ahead. So we need our broken line. So broken line, let's grab broken line and we'll go through these points. So through the points now, let's do that. And we are, and this is the disadvantage of doing it on the computer, we are going to have to extend that line right the way up through here. Okay, so let's just go ahead and do that. So let's put that there. So that's the line, and I would label this up. So on the graph, I just write that this is y is equal to, so y is equal to 2x plus 1. That's this line. Okay, so we want y less than and strictly less than. So if you want to see that that's going to be below the line, that's entirely up to you. You can go ahead and do that. We're just going to shade now below the line. Again, I prefer to test a point, especially when we look at some other examples. So I'm going to shade the region that satisfies this inequality, and it's going to be all values now just here. So let's go ahead and do that, and I won't spend all the time doing it, but hopefully you can see that it's going to be all values to the right of this line or below the line. So let's go ahead and just test a point. So if we test the point, what I'm going to do is take the point just here. So let's grab this point here. So I'm saying that's in my interval. So this point right here has the coordinates 2, 0. So if we look at this now, subbing it in, would we have now, is y going to be less than 2 lots of our value plus 1. So if I put this in, I'm going to have now the following. Y is going to be less than 2 lots of 2, which is 4, plus a 1, which is 5. And we can see quite clearly it's 0. And we can see that from the table. So just say to yourself, is 2 lots of 2 plus 1 bigger than 0? Yes, it quite clearly is. So we have the right one. Or if you like, you can just do it by saying it's below the line. Okay, right. So this time we've got exactly the same, but we've got 2. So this one, we've got our 2x plus 1, which was a straight line that we've just graphed. So if we just go ahead and graph that line again, remember we're using now 2 strict inequalities. So 2x plus 1, let's just go ahead and do that. Let's put 1, 3. I think it's going to look something like that, and then we'll just extend this. So this time, let's put my line on. That's going to look something like that. So that's that one on. We've also got to consider, and I appreciate that this isn't massively accurate, but hopefully it gives you some idea of what's going on. Let's just do that. There we go. And we also have to show now y is less than 2. And again, this is a strict inequality. So what we're going to do is have the line y is equal to 2, and it's going to be all values below this. So what I'm going to do is just write up now. So just writing this up. This is the line y is equal to 2x plus 1. So y is equal to 2x plus 1. And this is the line y is going to be equal to 2. So we saw now that in the last one, it was all values to the right of the line or below the line. But we also need it to satisfy the inequality that y is less than 2. And that's below the line. So what we're going to end up with, and I'll just shade this particular region right here, rather than doing 2, we're going to have this, and then we're going to have this right here. So this, the one that I'm doing here, is what we had before, but we can't go with 2 or higher, because it doesn't satisfy both. So this is what we had. And I think at this stage, what we could do is introduce a new notation. Often we call this the feasible region, and we would call this R, and we would just label it R. So this is the region that satisfies them. So often you would put on R. So let's just write on here. This is the region R. So let's grab a pen and we'll just put it here. So that now satisfies both. We can say that y is less than 2x plus 1 and y is less than 2. Okay. We're asked to shade the area that satisfies this inequality. So this time we don't have y is equal to mx plus c. We have 2y. So all I'm going to do is simply go ahead and rearrange this. I'm going to write this as y is equal to, dividing both sides by 2, 2x minus 3 over 2. So what we need to do now is draw this line. This is one way that we could do it. You can do it another way, and I'm going to show you that shortly, but this is what we're going to have. So again, if you're not confident with drawing a straight line graph, you're more than welcome to do a table of values. I'm just going to draw a straight line graph for this one, and what we're going to do is start with negative 3 over 2, so negative 1.5. So that's my y-intercept, negative 3 over 2, and what I'm going to do now is have a gradient of 2. So it's going to go up 2 for every one it goes across. So up 2 for every one it goes across. And let's just check that I get the right scale. So this is going to go up 2. So let's grab on the 2. So we're going to have on the next one, what we're going to have, 1 and then a half. So let's just put that on. That looks to be about there. Then on the next one, we're going to have 2, which is going to give me 3.5, which is going to be about there. So that gives me my line. That looks, let's just check I've got all of that right. So that looks to be a gradient. Let's check that. I'm just going to check that 100%. Okay, let's just move this one. This one needs to be at a half. That's a half. That's where I want it to be. So as you can see, just graphing this, you decide on how you want to do it. That's a bit fiddly to see. I think I've got that right now. So what we're now going to do is draw this. So I need a broken line. So let's go ahead and do that. Broken line through those points, and then just tidy this up. So that's the line. I'm going to label this up. And as stated, you could have done it with a table of values, and it'll look something, give or take, like so. So if we do that, that's our line. I'm going to just label this, and we can write on that this is going to be 2y is going to be 2y is going to be equal to 4x minus 3. So we want to now look at values that satisfy this. Again, if you want to say that it's going to be above the line, you're more than welcome to do so. We're going to shade now the region that satisfies that. That will be above the line. So let's go ahead and do above the line. Let's make that slightly bigger. There we go. And we're going above the line. If you're still unsure, test a point. I often like to test the origin if we can see the origin. So let's look at the origin, 0, 0. I've said that that's included, as all of these values are. So if we put this in, so the question is now putting the origin in. If we put the origin in, is 2 lots of 0 bigger than 4 lots of 0 minus 3? The answer is yes. We can see that 0 is bigger than minus 3. So I have the correct side of the line. If I pick this point right here, we've got the coordinates 2, 0. So we could say now, is 2 lots of 0 greater now than 4 lots of the x-coordinate of 2 minus 3? Is 0 greater than 5? So that's 8 minus 3, 5. The answer is no, so this is not the interval. So this is the region R that we would want. So you can either test a point or you can look at essentially seeing which way the inequality is pointing. Okay, so that's that one done. Right, we're asked to shade again the area, and this time we've got x plus y is equal to 5. This is very in keeping with what problems involving linear programming. You've got two choices here. What we could do is rearrange this into the form y is equal to mx plus c. So we could say that y is going to be less than 5 minus x and draw the line y is equal to 5 minus x. My preferred choice is to set x to 0 and consider what y would have to be, and then set y to 0 and consider what x would have to be. So if I said x plus y is equal to 5, and we said that x was equal to 0, then y must be 5. If we set y to be equal to 0, we can see that x plus 0 would have to be equal to 5. And that just gives us the point here, which is going to be 5, 0, and then 0, 5. So all I do is draw a straight line through. So it's entirely up to you. Again, this is a strict inequality, so we can't include the values that sit on the line. So what I'm going to do is just do that, and it's going to look something like so. So let's come through here. And now at this stage, you could think to yourself, well, I'm going to look at the way the arrow's pointing. Alternatively, I like to test a point. Now, if we think about this here, 0, 0, if I take this point, is 0 plus 0 less than 5? The answer is clearly yes. So what I'm going to do is shade now below the line. So on here, we're just going to do all of the values that satisfy this, and it's all of these right here. So again, up to the line, nice ruler, it's all of these. If I picked a point somewhere here, let's say this one right here, and I picked now 0, 6, if I put this in, we can see it doesn't satisfy that inequality. So from here, if I wanted, so I would have x is 0 and y is 6. Well, that's not less than 5. So with this way, I've just done it slightly differently. So on the last version, we considered now shading above the line here, but with this one, it's entirely up to you. I think this is a nicer way to do it. Just consider when x is 0 and y is 0, draw those 2 points, which of course you can do with this one. You could set, for example, on here, x equal to 0 and y equal to 0 and find those points. Really is up to you. It's kind of open for you to look at. Okay, so let's look at this one right here. So what I'm going to do with this one now is consider when y is equal to 0. So if y is equal to 0, what we can see is that 5x would be equal to 10. And that gives me that x would be equal to 2. So if I'm going to draw the line 2y, so 2y plus 5x is equal to 10, that's what I'm going to have. If we consider when x is equal to 0, we're going to have now that 2y is equal to 10, so we can say that y is going to be equal to 5. So straight off, I'm going to go ahead and do it. So that's an alternative for you rather than graphing a negative line. So let's find those points. So we're going to have 2 naught, and we're including this one, so we need a solid one. So we're going to have 2 naught, and we're going to have 5 0 5. So let's do that and do that. So it's going to look, give or take, like so. So let's go ahead and extend this. Again, I like to, at this stage, test the origin. So if we test the origin, let's just bring that right way down. We're going to test the origin. Now the origin is 0 0. Is 2 lots of 0 plus 5 lots of 0 at least 10? The answer is no. So by just choosing a part right here, I can say that this is not included, therefore I want to go above the line. So just labelling the line up, 2y plus 5x is equal to 10. We're going to shade now the region that satisfies this, and that's going to be all of the values that are above or on this line right here. Again, my shading won't be brilliant, but it gives you some idea. So it's all of these values right here. Do remember to label up each line, because if we've got 3 or 4 on the same graph, we need to know which ones are which. With some linear programming problems, you're going to have to solve the inequality, and it will be the intersection of 2 of these lines, so it's important to label them. Okay, let's look at this one right here. So this is exactly the same, but it says now that x must be less than 3. So it's exactly what we have. So all we'll do is just go ahead with this one. So we'll use this, and it's x has got to be less than 3. So broken line, and I'm going to do it on this one to save me drawing another graph. And this is the line x is equal to 3. So I'm going to label this up now. So let's go ahead and do that. So we want to label this up, and we will just say that this now is x plus 3. So x is equal to 3. And we want values now that satisfy the inequality that x is going to be less than 3. So that's all values to this side of the line. But it must also satisfy this inequality. So all we've got for this particular one now, remember we would be doing all values to the left. We've only got this one, let's just change it over. We've got this particular region just here. So it's going to be now down to the point here, and then we're going to come up here like so, and it's going to be, and obviously we would be to the left of that line. My shading isn't brilliant, but the values that will satisfy both of these are those shaded here, red and yellow. So that now gives us those. Because if we look here, this side, it doesn't satisfy both inequalities. It satisfies one, but doesn't satisfy the other. Over here, it satisfies that x is less than 3, but doesn't satisfy that 2y plus 5x is at least 10. So there we go, shading 2. So slightly harder with that one. Right, okay. What we've got now is a wordy question. It says Fred wants to hire 2 types of car. One type is a 4-seater and the other is a sports car. He needs at least 12 cars in total, but wants to have less than 5 sports cars. Represent the information on a graph. So let's define what we call our variables. So we're going to have now our variables, and I'm going to write them here. I'm going to say the following. I'm going to say let x be equal to the number of the 4-seaters. So I'm going to write this here of 4-seaters. I'm going to let y be equal to the number of sports cars. So the number of sports. What I'm doing is formulating essentially a linear programming problem here, and there were plenty of videos if you go on to linear programming on these. So this is the number of 4-seaters, this is the number of sports cars. What I'm going to do is pick the information out from here and then go ahead and graph it. The first thing I can say now is that x and y must be at least 0. This is what we call a non-negativity constraint. I can't have minus 10 4-seater cars. So both of these have got to be at least 0. So the number of 4-seaters and the number of sports cars must be both at least 0. He needs at least 12 cars in total. So what I can say is that x plus y So the number of four-seaters plus the number of sports cars must be at least 12. So we can say is equal to or greater than 12. He wants to have less than 5 sports cars. So from this we can say that y must be less and strictly less than 5. So what we need to do now is go ahead and graph these. So the first one means that all of these values this side are excluded, and this is what we call non-negativity. So we're only interested in this particular area here. So straight away we've not got these ones, and we've not got these ones right here. Let's do this one. X plus y is equal to 12. That's the line I'm going to draw. So if I have x plus y is equal to 12, we can have 0, 12, and then let's just tidy that up. We can have 0, 12 and 12, 0. And that's going to look something like that. So what I'm going to say now is the following. So just writing this on, this is the line x plus y is equal to 12. So x plus y is equal to 12. We want it to be greater than 12, so quite clearly we're going to go above the line. Testing the origin here is not going to give us a number. So 0 plus 0 is not 12 or more. I'm also going to put on that y is going to be less than 5. So at the moment I would shade all of this region right here to say that's included in the first one. What I'm now going to do is have y is less than, strictly less than 5, and that is going to be just there. So let's go ahead and put that one on, and that is y is equal to 5. So just writing this on, y is equal to 5. So I need all of the values that are above the pink line, yet in turn less now than the blue line, but are still positive. And what I'll do, I'll just put these on here. I'll just put up the next constraints. Let's see if we can do this on the axis. So the x and y being greater than 0 would look something like this. So let's do that. And we might want to label those up, but generally speaking, we wouldn't. So if I look at the region that I want, I can just go ahead and go straight to this. So it's got to be above the pink line, below the blue line, yet above the black line. So it's going to be this particular region just here. So that is above the pink line, it's positive, and then it's going to be below this one right here. So what we can see, and obviously it will keep going in this direction right here, we can have now other values going in here, and we can keep going. If we think about what the actual question is saying, is he needs at least 12 cars. He could have, well, essentially millions and millions of the X values, which are the sports cars. So this is just going to keep going over here. We're just graphing it for these values. Now you might even be told another constraint. But what we can do at this stage is look at possible combinations. In terms of this particular problem, it's not hard because we can just pick a load of problems by writing them down because it's fairly straightforward. So if we think about it, we can have now in terms of the y's, we can have 4, 3, 2, 1 or 0 because we've got to have less than 5. But if I just pick some points here, what we can see is the following. We could have this point right here. So we could have 8. So we can have 8 of, remember this is the 4-seaters, and 4 of the 2-seaters. So this is our y. So all of these satisfy. Another one that satisfies it is going to be the 10 and the 2. So we could have 10x and we could have 2y. So we can see on here that if we had 9 and 3, that also satisfies it. All of these do as well. So for example, 10 and 4, we could have 12 and 4. We can have 14 and 4. So these are just different integers that will work. So 10 and 3. I couldn't have this one though. I couldn't have 10 and 5 because I've got to have less than 5 of the y. So that's setting a problem up. Okay, so we've done those, we've graphed them, we've drawn them. Let's now go ahead and look at seeing if we can interpret shaded regions. Okay, so state the inequality or inequalities shown below. So we're taking the shaded region to be the part that we want. So what line have we got here? This is the line y is equal to 4. we can see that it's a broken line, so we're going to say that y is going to be less than 4. So if we were asked to state what this inequality says, well, it's y is less than 4. If we look at it, we've got now 3, that could be included. We've got 3.5, we've got 3.7, we've got 2, we've got -2 or -2, we've got 0. So this now is the represented inequality. It's just 1. So for example, if I put on another one, let's go ahead and do this. So if we had, for example, this right here, that is going to be the line, and I'll move that. In fact, let's just give the x value. Let's say that we moved it to here. And we then thought about values this side. We could say, now let's put this on, say if we had another shaded part here. These now are all values that are going to be 6 or more. So x is going to be equal to or greater than 6. So that's those. Of course, if we come down to this particular interval right here and just changing this over, these now are the values that satisfy both. They're at least 6 for x, yet in turn less than 4 for y. So that would, if I wanted to change it, that's what we'd get. Okay, so this one now, state the inequality or inequalities shown below. So we've only got one variable again, and this now is x. That's -1. We've got a solid line, and we're to the right of that, so we can say on here now that x, and just writing it on, x is going to be equal to or greater than -1. So we could include -1, we could include -0.5, 0, 1, 2, but we couldn't have, for example, -3. So that is showing me the inequality that's represented. This is the region, these are the values. Okay, right, what have we got here? Well, this is a straight line, it's going through the origin, and we can look at the gradient. So if we look at this point right here, that's going to be 1, this point's going to be 2. So this gives me 1, 2. If I look at this point right here, this is going to be 2, 4. If I look at this point right here, that's going to be 3, 6. So slightly harder this time, but we can see now that this would be, if we just had a straight line, it would be the line y is equal to 2x. So what have we got here? Well, we've got a broken line, so we know it's going to be an inequality, and or strict inequality, I should say. And then if we think about this, we're going to have on here that y is going to be strictly less than 2x. If you're unsure, you can go back to the idea of shading above or below the line, or you could test a point. If we look at this point right here, we've got 2, 0, which is included. Is 2 lots of 2 bigger than 0? Yes, it quite clearly is, so that is the correct interval. Yet if we pick this point right here, 0, 4, is 0 now going to be less than, or should I go around the other way with it, is 4 going to be less than 2 lots of 0? No, it isn't. So I've looked at the gradient of this line. It would be the line y is equal to 2x. All I've done is gone ahead and redone it from there. Okay, let's look at another one. So state the inequality shown. So what have we got here? Well, we've got this point right here, and we've got on here, this is going to be 0, 6, and this is going to be 6, 0. So what we can say for this particular case is that this line is going to be now x plus y is equal to 6. Alternatively, you could have said that y is equal to 6 minus x using the gradient intercept method. I prefer this particular approach. So let's now consider what we've got. We've got a solid line, so we know that it's going to be inclusive. And if we just test this point right here, 0, 0, we can see quite clearly that x plus y, if we have this now, is not included, so it's going to be equal to or greater than 6. So test the point 0, 0. We can see that this is not included, as 0 plus 0 is not at least 6. Yet if we take this point just here, for example, that is 4, 4. We can see 4 plus 4 is definitely 6 or more. We can see this point satisfies it. So this now is the inequality shown on the graph. Okay, let's try one more. What have we got here? So we got 2. Now, what we've got are 2 different inequalities, and we're going to look at this region right here. Okay, this is a region that I want. So we've got this one, this one. So when you're actually given this, you'll probably just have this part right here. So if we look at this one right here, this we got 0, 4 and 4, 0. So with this one, we can say that this is going to be x plus y. Now, strict inequality, and it's including the origin, so it's going to be now less than 4. So let's just test that point. 0, 0. Is 0 plus 0 less than 4? Yes. So that's this one. This is the red one. If we look at this one, this is the line x is equal to 2. Broken line, so what we can say then is the following, that this is going to be, x is going to be strictly greater than 2. So at this stage, what we can do is go ahead and write down this particular region right here, which I'm just going to do, and that is the one that satisfies both. So what we can say is the following. We can say, and writing this in, x plus y is going to be less than 4, and we can say that x is going to be greater than 2. So we've got two different inequalities satisfied, and that gives us this region right here. So there we go, just over 40 minutes. I didn't envisage it would take so long, but that's looking at graphing inequalities or shading regions.